famous 12-factor app document specifies, in factor number 6, that you should execute the app as one or more stateless processes. The keyword there is stateless. The authors go on to declare that any data that needs to persist must be stored in a stateful backing service. This topic is often cited by architects for its value in simplifying scalable software and packaging, as well as providing deployment efficiencies. But there is strong security value associated with it as well. If a process is stateless, then it should be able to run in an immutable environment. Immutable, adjective, unchanging over time or unable to be changed. When it comes to file systems, this generally means read-only. And for containers, we already start with a write once, read many, or worm design for their image. At runtime, the container engine places a read-write layer on top of that for state changes by default. But that default can be overridden to not include that layer. In Docker, this is done by adding the read-only argument to the Docker run command. In Kubernetes, we achieve the same thing by setting SecurityContext readOnlyRootFilesystem to true. If the process cannot mutate the file system on which it runs, then an exploited vulnerability in that process cannot be used to add, remove, or patch executables on its file system. Thus, the attacker has one less platform from which to launch attacks. For example, when a container is started without a read-write layer, an attacker exploiting a remote code execution in that application cannot download anything else onto the container's file system to expand their attack. Well, I can't download anything onto this system. And there's nothing else installed here that's useful to me. Let's go find an easier target. While the read-only file system setting is a great tool, it does not extend to volumes mounted into the container. Exercise caution when using them, or consider externalizing those portions of your application to other services, such as streaming logs to a collector or storing application data in a database. Haha, cool. Now that I've broken into this application, let's start encrypting their files so we can extort some sweet Bitcoin from them later. Oh, it's all read-only. I better wipe my logs to cover my tracks. Oh, those are being forwarded off to some log server. I better get out of here. As is always the case, security is best delivered in layers. Restricting the ability for a bad actor to add their own software to your container file system is important, but not if the files already in the image are vulnerable. Be sure to couple this tool with continual scanning of your container image and application libraries for vulnerabilities. The Snyk suite of scanning tools can identify and provide fix advice for all these layers for free. Simply sign up for your free account at snyk.io, and you can start scanning your application, Docker files, and Kubernetes manifests today. Restricting file system mutation is important, but it's not the only tactic available to you. SecurityContext has many other settings, such as restricting root owner processes, which I discussed in our prior video. Check it out if you haven't done so already. We published a cheat sheet that goes into details about these settings as well as other ones available to you in the SecurityContext API. I'll include a link to it in the description below. This video covered topic 7 from that article, and I'll be posting more quick hit videos like this one, covering more of those topics soon. Thanks so much for watching. Please join us again for the next one.